Welcome to Brain Vision.
We're dealing with the acid, hydrobromic acid, HBr, which will dissolve solid iron according to this reaction. Forms iron 2 bromide and hydrogen gas, and then we'll need to balance. And first up, we want to know what mass of hydrobromic acid do you need to dissolve 3.2 grams of pure iron on a padlock. Now this is stoichiometry, so we're going to start with the information that we were given, which in this case was 3.2 grams of iron. From there, we need to get to a mole ratio and then to the item that we have desired. To get to a mole ratio, we have to convert to moles, and in doing so, we'll have to use the molar mass. According to the periodic table, iron has a molar mass of 55.8 grams for every mole. And according to our equation, we have no coefficient for iron, so our mole ratio will have 1 mole of iron. Now, we were looking for what mass of hydrobromic acid. So now, we'll look at hydrobromic acid for our mole ratio and see that it has a coefficient of 2. 2 moles of HBr. And we wanted to know what mass, so we'll need to convert from moles to mass. Now, hydrogen has a molar mass of 1 gram per mole, and bromine has a molar mass of 79.9 grams per mole. So I'll add them together and find that it is, in fact, 80.9 grams. If I did this correctly, all of my units should cancel, except for what I desired, which was grams of HBr, which is correct. Once this is all calculated out, so we would multiply 3.2 grams by 2 by 80.9, and then divide by 55.8, we would end up with 9.3 grams. Because our answer can only have 2 significant figures since we were only given 2 in the first place. Now for part B, we want to know what mass of hydrogen can be the complete reaction of the iron bar produced. So we'll start with the same figures. 3.2 grams of iron. We'll use our same molar mass to get to a mole ratio. And this time we want to work towards hydrogen, so let's do so. Hydrogen has no coefficient, so it would be a 1-to-1 mole ratio. And then for every mole of H2, according to the periodic table, every mole of hydrogen, a singular atom, is 1 gram per mole, but we have 2 of them, so it'll be, 2 grams of H2. So once again, I'll check my units and make sure they all cancel. And they do, and we'll be left with what we're looking for. And in this case, again, 2 significant figures. This would work out to be 0.11 grams of hydrogen once rounding it down to 2 significant figures. So that'll be both answers right there.